Hi everybody, this is an optional video for you. I decided after today's class to just go ahead and make a video walking through how to make a plot in Excel and some of the things I talked about in class, but just for those of you who may want some extra practice with spreadsheets, just to see how I, somebody who's done this for a while now, walk through doing something like we did in class. So I'm going to do the same activity we did in class, where I'm plotting the Blackbody radiant energy density equation, Planck's equation, versus wavelength. But I'm just going to start fresh from a blank worksheet. And this is in Excel instead of Google Sheets, so things are going to be slightly different. But same basic idea as what we did with Google Sheets today. So like I mentioned in class, one of the things that we're going to want to do right up top is establish all of our constants that we're going to use. So in our equation, we know that we have Planck's constant h, we have the speed of light c, we're going to have the Boltzmann constant kb, and we're going to have temperature, and that's something we're going to change. It's good practice just to keep track of your units. So we'll do the units for everything on the side here. And when you put it on the side and not as part of the actual constant, because Excel will treat that as text instead of a number. Okay, so H, 6.6, number lock is off, 6.626 E minus 34 is 6.626 times 10 to the negative 34. This is how you write scientific notation in Excel. And it treats that just as a regular number. You don't need an equal sign before that. Whereas if you write it as a formula, 6.626 times 10 raised to the negative 34, that would need an equal sign before it. It would give you the same thing. Speed of light, 2.998 times 10 to the 8th meters per second. The Boltzmann constant, 1.381 times 10 to the negative 23rd. And then we'll start at room temperature, 300 Kelvin. Now we can format these cells in different ways. So if I select them, most of these, putting them in scientific notation is fine. But let's say temperature, say we want to put this in a more normal format. We can go right click here, go to format cells, and then we get lots of options of how we can display our numbers. So we can display, it's currently set to scientific. We can just go to regular number, tell how many decimal places we want, or we can just say general. It doesn't have a specific number format, and that'll be 300. So it doesn't have the scientific notation anymore. Okay, so the next thing we're going to want to do is our x-axis is wavelength, lambda, and we'll express this in nanometers. And we're going to need a bunch of different x values that we're going to plug into our equation, so just like I showed in class. And so we'll go every, say, 100 nanometers here. So we can't start at 0 because the equation's undefined at lambda equals 0, and there's no such thing as 0 wavelength. But let's say we'll go every 100 nanometers. So once we establish a pattern here, I can select these, take this square in the bottom right, and if I drag this down, that'll give me, I've already dragged down to 400, right? So we've got 438 points here. So this is out to 43,000 nanometers, or 43 microns. That's plenty. We probably don't even need quite that far. Okay, so that's our x values, and then our y values are going to depend on x. So this is our row function that we want to plug in here. Now to make a formula, we need to use the equal sign. And there are kind of two different ways Excel can work here. If you type directly into the cell like I have it here, if I click on another cell, it'll insert it into my formula. So say, for example, first we have 8 times pi. And the way to write pi in Excel is you write pi for pi, and then an open parentheses and close parentheses. Pi is technically a function that returns the value of pi. And for Excel to recognize something as a function, it needs open and close parentheses. You don't have to put anything in those parentheses for pi. It's kind of a special function. Most things you would need to put something inside of it. We'll see that with the exponential function in just a minute. All right, so 8 times pi times h. And since I'm typing directly into the box here, I'm pointing, but you can't see my finger. When we're typing directly into the box here, we can just click on this, and it'll put in our C2. Now, as I talked about in class, we want this to not change, even if we move, copy and paste the formula around. And so we need to put the dollar signs on this constant. We can type the dollar signs in directly. There's also a keyboard shortcut that lets you cycle through different these are called absolute references where it doesn't change. And that's the F4 key. So if you push F4 while your cursor is where this cell is, the first one it'll do is dollar sign for both the row and the column. And that's what we want in this case. If you keep pushing F4, it'll switch to only the row or only the column or back to neither one. Right, so F4 allows you to toggle through those without needing to type in the dollar signs. All right, so we have 8 times pi times h times c. And we also want that one to be an absolute reference. And then we need to divide by lambda. Now we need lambda in meters. Our current version is in nanometers. So we need to multiply this value. And one thing I just did there is I hit the F2 button, which switched to edit mode. That won't allow me to click. That'll allow me to move my cursor around using my arrow keys without selecting cells. Whereas now I'm not in edit mode. And you can see it down the bottom left of my screen. It changes between edit and enter. Edit mode lets me move my arrow key left and right. Enter mode, if I push left and right, it selects other cells. All right, so you go back into edit this. All right, so we need to take this wavelength, which is in nanometers, and change it to meters. So we need to multiply times 10 to the negative 9. Right, so everything needs to be in the same units for things to cancel. Since our speed of light is in meters per second, our wavelength needs to be in meters. Okay, and then that whole thing gets raised to the 5th power. All right, so that's the first half of our equation. And now we need the part that has the exponential in it. Okay, so we multiply this times 1 over exp. So this is our exponential function. This is the way we write exponentials in Excel, and exponentials show up a lot in this class. So this is a very useful function to know. And then we open parentheses, and everything inside there is what's going to be inside of our exponent in the exponential. Okay, so we need h, absolute reference, times c, absolute reference, divided by, and you put parentheses here so it's divided by all of these things. Lambda, and again, with lambda, we need this to be times 10 raised to the negative 9, so that it's in meters. All right, so lambda times the Boltzmann constant, absolute reference for that one, times t, absolute reference. All right, so double checking my parentheses. I need another set of parentheses. And Excel does color code them. I can't remember if Sheets does this or not, but you can see my right parentheses is red, and the other side that's red, the left parentheses that's red, is all the way back here at the beginning of the exponential. So I have another one that's kind of purplish, that's right over here that matches, and then a greenish one for this set of parentheses here. All right, so we have all of that. That's inside the exponential, minus 1. All right. Now, you see, I happened to get something that didn't give me an error the first time. Now, that's partially because I've used Excel a lot. So that's part of what's going on here. This value seems too big to me, though. I still think I made some sort of error. It's just not one that Excel is... Oh, I see my error. And first thing to look at our parentheses, and then plus and minus signs, right? I missed a negative sign for my 10 to the negative 9 here. All right, something very, very small, that seems right. And then now that we have this formula, I don't know if this works in Google Sheets, but in Excel, if you have a set of numbers to the left here and you want to copy this formula for all of them, you've got all your absolute and relative references correct. You can just double click on this instead of dragging it the entire way, and it'll automatically fill in for as many cells have values in the column to the left of it. So that's a useful shortcut. That's really helpful. Okay, and so that should give us our all of our values. And so we can see, do these make sense? They're really small at very large, small wavelengths, which makes sense. They get bigger, gets up to a large value, goes up, and then goes back down. Yeah. Or is it still increasing? Okay, it starts going down there. All right, so the numbers look like they make sense. And we want to go ahead and plot them. So I'll go ahead and do this without selecting the data first to show you how to do that. So we go up to insert here, and we want a line, not chart, we want charts here. We want a scatter plot. That's almost always what we want when we're plotting things from chemistry. We don't really use bar graphs or pie charts very much in chemistry. So it's almost always this one we want, XY scatter plot. And depending, if we want to emphasize individual points, we can do this type, but we're going to use this one that doesn't have individual points, scatter with straight lines. That's usually the best one to go with. All right, and so that'll just make a blank one. And what we have to do is we have to right click on it and select data. So that's what we want. Okay, and so we click add here. So we can give our series a name if we want. So we could say Blackbody. And then we want the X values. And so we can type this in as like an Excel formula, but what's easier is to click this button here and then select. And this is one of the handiest keyboard shortcuts in Excel. Every time I tell students about this, they are very excited about it. So if you want to select more than one cell at a time, you can hit Shift and move your arrow, use your arrow keys to go up and down, and that'll select multiple cells. Another useful Excel shortcut is if you press down the Control key and push an arrow key, it'll go all the way to the last entry and last thing that has a value in that column, or if you go to the right in the row. So if I hit Control and go back up, it'll go all the way back to where my label is, where I say lambda. You can combine these. If you hit Control and Shift and then hit down, it will select everything from where your cursor is down to the bottom. So rather than having to click and drag over this entire thing, it'll automatically select everything. We can go back here and we can use the same trick with the Y values. So again, click the one that we want to start with, Control, Shift, hold those down and hit down, and it'll go down to the final value in that column. And then we hit OK. We don't need to worry about the axis labels here. And now we need to scroll back up. But here's our Blackbody curve, right? And so we can see at 300 Kelvin, we get this peak out in the infrared. This is, at room temperature, things, have a peak in the infrared. Obviously, they don't glow in the visible very much, or else we'd notice it. We'd see them glowing. And if we increase this to, say, 1,000 Kelvin, the peak shifts significantly to the left, and now it's we get significant visible light. And we can take our axis here and change the properties here. So if I want to zoom in on the x-axis, the way to do this in Excel is you double click on the axis down here. You can set your maximum and minimum. So let's say I just want to look at the visible portion of the spectrum. So that's something like 350 to 800 nanometers. All right, we'll have to scale the y-axis too. 200 is too big, so maybe 20. Not even. Maybe 1. Right, so now we're starting to see some of the points here. And if we increase this even more, 3,000 Kelvin, now things have gone off the top end. We have to increase this again. 20 is not enough. Maybe 1,000. Oh, it's 10,000, 20,000. Let's do 100,000. All right, so now we can see we get a significant amount of visible light that's happening at 3,000 Kelvin. And we can double click down here, reset these axes so we can see the whole curve. All right, so hopefully this is useful for those of you who have a little bit less experience with Excel. Or if you have, even if you do have some experience, maybe you learn some new tricks. All right, see you guys later.